ways today, and you guys can figure out which way you like better. So let's look at way 1. Way 1. For both ways, we're going to use the same exact function. Do y equals log base 3 of x plus 2 minus 1. Do you want to do the algebra way first, or do you want to do the transformation way first? Algebra. Thank you, Mark. Okay, first off, we need to find our asymptote. In our original one, it was the y-axis. Let's check for this one. I'm going to take my argument. Let's label the argument. This part right here is the argument. I'm going to take that, do x plus 2, set it equal to 0. Find asymptote. I'm shortening it to that. What is my x equal, Hawaii? Yep, minus 2 from both sides. X equals negative 2. So we have an asymptote at x equals negative 2. Great, that's the first thing we have to do. Second thing, I'm going to take the argument still. X plus 2, x plus 2, x plus 2. I'm going to write it 3 times. So I'm going to set it equal to 3 different things. I'm going to set it equal to my base, 1, and 1 over my base. What is my base of this function? Yeah, 3. I'm going to go back to blue. So I have x plus 2 equals 3, x plus 2 equals 1, and x plus 2 equals 1 over b. These are going to give us nice values, so it's easier to graph it. Not b. We said b was 3. Perfect. Solve all 3. See what you get. These are going to be your x points. For your table. I'll make a table. Let's show a table with those. Okay. What did I get for my first one? Yep, x equals 1. What did I get for my second one? I'm not going to write there, actually. X equals 1. What about my second one? Subtracting 2 from both sides. Yep. Negative 1. Next one. Yep, negative 5 over 3. X equals negative 5. This one? Yeah. Okay. Minus 2 from both sides. Minus 2 from both sides. X equals 1/3 minus 2. I need a common denominator to subtract these two. So I'm going to do x equals 1/3 minus, I put a 3 in the bottom. So I'm multiplying the bottom by 3. Multiplying the top by 3. So I get negative 6 over 3. And I'm just subtracting across, so negative 5 over 3. Yeah? Okay. Let's make a table with these points. I'm going to make it 3 columns because we're going to have to do some math. I'm going to put my 1 up top, my negative 1, and negative 5 over 3. What is in my second column? Yep, my function. log 3 of x plus 2 minus 1. And then my y values are on my other side. Now, I already did this middle section right here, right over here. No, that's how let's just plug it out twice. When I do log 3, plug in my 1 plus 2, negative 1. 1 plus 2 is 3, so we have log base 3 of 3 minus 1. Anyone know what log base 3 of 3 equals? Do you guys want to put it into exponential form? Yeah? Okay. So if I do this, let's log base 3 of 3 equals y. Put that into exponential form. Yep. Okay, 3 to the y equals 3. So what would y equal in this situation? Negative 1? So this would be 1 minus 1. Yeah. So 3 to the 1 equals 3. So 1 minus 1 is 0. Cool. Now let's try the next one. We have log base 3, negative 1 plus 2 minus 1. What is this going to simplify to? Is that my log? Negative 1 plus 2. 1. Negative 1. So what would this simplify to? 3 to the what power gives me 1? Yep, 0 minus 1 equals negative 1. You see a pattern here. B is our base. Our base is 3. Next one, when you said equal to 1, we have 1. Guess what our next one's going to be? What was my third thing I set the argument to? 1 over, yep. So we have log 3 of negative 5 over 3 plus 2. And we just said that's going to equal 1 minus 1. Nope. 1/3 minus 1. So you see here, this is our base. It's always going to be 3, whatever the base is. Next one's 1, so next one's 1. 1 over b, 1 over b. We got that by finding these nice x values. That's why we found these nice x values. So that our logs would be easy to solve. So 3 to the what power gives me 1/3? Do you want to rewrite the log in exponential form? I want to. So this could be 3 to the what power gives me 1/3. I think Angel just said it. Yep, negative 1. So this equals negative 1. So from here, we get negative 1 minus 1. What does that equal? Yep, negative 2. Do we want me to go over any of the math to get the y points? No? Okay, let's graph it. And what should I start my graph off with? What was the first thing we started with? What was number 1? The asymptote. Yep. I want to put my asymptote down at x equals negative 2. And then I want you guys to graph the rest of the points. Anyone want graphic decisions?
I gave 1 to each group at the start.
If you're done, find the domain and range of the function. Don't forget to extend your graph.
These are
Okay.
cross horizontal.
Yeah. I'll show you in a second. What is -5 that's really, really close to? 2. Really, really close to, but not right there yet. So let's start with the difficult point. Let me label this. So we go over really, really close to x minus 2, but it's not exactly there. So like roughly right there. You can estimate it. Then we went down 2, so I'm right there. My next point is -1, -1. So that's right here. And my next point is 1, 0. Now I gotta connect them. And it keeps extending into both sides. Oh, that's so much better drawing than 6 hour. It was very wonky 6 hour. That's a lot better. So that's my function. What was my domain and range of it? Greater than -2. What about my range? Yep. What is my asymptote? X equals -2. And then someone that's not Liam, what is my x-intercept? X-intercept is a point, so I want a coordinate. Yep, 1, 0. Great job. That's it. Easy or hard? Meh. Do you want to see a second way? Okay. I'm gonna wait until you all get this down first. We should extend this into both directions because we could have kept going with the points in either direction. But it's never gonna cross the asymptote. Never crossing it. The whole thing shifted over to the left 2 because we had a +2 up above. And it shifted all down 1. Angel, are you done writing or are you just sketching? Okay, good. And I ran out of room. Okay. We're going to start with the same function. This is just, oh, I'm not going to choose this color. Call this way 2. This is mostly focusing on transformations. We have y equals same function. Log base 3x plus 2 minus 1. Liam, what was my first step before? Yep, we're going to do that again. Oh, we should start with this. I'm going to set my argument equal to 0. We got x equals negative 2. That's what y told us earlier. Still true. Okay. Next step is a little different. We're kind of going to start with our y values. I'm still going to make a 3-column table. I'm going to tell you right now, I'm going to start with my y values. That is negative 1, 0, and 1. Now, I'm just going to look at my base function right now. Just this part. This is my base function before I do any transformations, before I shift it in any direction. I'm just looking at that right now. You want to put this into exponential form? Or do we like log form? Ronaldo, which one do you like? Just pick one. Exponential. Great. You listen to the passion. What is this in exponential form? Yep. 3y equals x. So if you need it, we can do 3y equals x. And we have the x's over here. What did we set the argument to last time? What was the 3 values? Yeah, why 3? Yep, so we did the base. Oh, we did the base. We did 1, and we did 1 over b. Guess what? If I plug in all these y values, I promise you this is going to come out. Let's test it. So I have 3 to the negative 1 equals x. What does x equal? 1/3. Ooh, that's 1 over the base. What about 3 to the 0? What does that equal? 1. 1 again. 3, what's my base again, King? What's my base in this problem? Look up here. What's my small little subscript in log? 3. Yep, so we got 3. So we want 3 at the end. So we put the 1 there, because that's our y. What do we get out? 3. Great. So we got our 3's. Each time, let's write this down. So for way 2, start way 2. Start with y values. Always. Negative 1, 0, and 1. Then we look at the base function. Which in this case is y equals log base 3 of x. Okay? Just not with the transformations in there. Everything without the transformations. And x values, then, x values, ooh, it's delaying my writing. Okay, then, oh, there we go. Then x values are 1 over b, 1, and 3. Well, b. Which would be 1 over 3, 1, and 3 in this problem. I'm going to put you a star right next to the next thing I'm going to say. We'll see this in the next problem, but I want to make a point now. Unless base function is negative. Then we just switch 1b and b. Because what line are we reflecting over? X-axis. We'll go over that in a minute. I know that was a lot of information. But we just did it. We're just putting it into words. Kennedy, we're not done yet. We're not done yet. We still have to look at our transformations. So I look above. I have a +2 and a -1. What does that +2 mean? What's happening to our graph? Okay, I heard a lot of 2, 2, 2, 2, 2, but I didn't hear the first part of it. What? Left. Yep. So we're going -2 to our x values. What does this -1 mean? Going up or down? Down. So we're subtracting 1 from these values. So I'm kind of extending my table. I'm subtracting 2 from all these values. I'm subtracting 1 from all these values. So -1 minus 1 is -2. 0 minus 1 is -1. -1 minus 1 is 0. So 1/3 minus 2. Kennedy, you know what this is. I know you do. 1/3 minus 2. Yeah, -5/3. -2 plus 1. -1. 3 minus 2. 1. Are those the same exact points as we got before? Look up. Yes, the order is different, but that's okay. But are those the same points we got in way 1? Yep. You don't have to graph this one unless you want to, but you already graphed it before. Okay. We're going to do another problem, and I want you to pick whatever way you like better. And we're going to do this in partners at our tables. Okay? Okay. Does anyone have a way they already prefer? What? Wait, 2? Okay. Y equals 2 log base 5 x plus 3 minus 1. What is my argument? Yes. X plus 3. Start with that.
You can here. Let me get you knocked out. I hate to do that.
Yeah. Yeah.
The base is the 5.
Yeah. Mm-hmm.
So I would start with I would call it there. Yeah. What's the base?
Instead of 2, would it be 3?
So you give me the whole thing. What yours? Base 5 of x, and then everything else. We way 2. Our base of parent function is log base 5 of x. And then what's going to happen?
Go to this
Left or right? Good. And what happens to y? Yeah, so just subtract. So we can do the table the same way. You're going to take your y first thing. So if you're doing way 2, make your xy table. So is there a negative right here? So if it were negative, these would switch. So, but it's not something to like.
Yeah, and now you have to just try transformation. So what's happening to the x over here?
So you should use this double tab or maybe try to
So when it's in the function, you always try to take calculus. I don't know why. I mean, I know why. But it's like weird. I know. So we're going negative 3 for the x.
Yeah, and then I'm going to show you some great ones. I would suggest you like this way. Like this way.
It'd be 15 over 5. That'd be negative. Yeah.
And then you told me one. So like on this one, let's make that right there. But I just think it's like that's how I the logs are easy enough to think
So
about.
I like put so these are the x values.
She says 3 of them happen. That's base to address. Yes, sir.
14 over 5.
All right, are we doing way 1 or way 2?
Wait, now which way do you want to do?
Okay.
So let's put function. So that's how many outlets. So if the 2 times the log is 5. Oh wait, yeah. So x equals it is.
Okay, so let's check this out. You're doing some scratch work over here.
8 plus 4.
Right, just this one.
So putting that in for x and makes all that.
That's it. Okay. Oh, so write 2 logarithms of 1. And we're just plugging it in. We're saying you can, whether you actually show that or not, is up to you. Here's how I would do this. Right?
Then you have 1 second inside 1.
Bring it really back. Like, we're gonna, so, we're putting it up 1, because that's part of the 1. And what I do, I would like to. Every single time. That's what a log does. Good. And what goes here? So if we're doing weight. So 1 over what's up here? So 1/5. 2. I'm doing 1. And then scratch work. That would have been awesome. I didn't think it was so can I? For real, I'm right here. Are you okay with?
If you guys are done, graph it, find the domain and range. That's going to be your function. I would put the entire thing as the y, put it right in the middle.
We used to not have this.
Yep, so if we're doing a lot of this,
All the teachers.
you agree that log makes me that's pretty well. That means you have the power. Oh yeah, I understand that.
Inside this bracket is everything outside.
So 5 to the 0.
You're doing wait. No, I'm yeah. Okay, so you don't get wait 1 3 4. Make I would make a 3 column table for that one. What? Okay, which way do we do? 1 or 2? Should we do a tally? I don't want to do a tally. Okay. 1, 2. Raise your hand if you did 1. Okay, hands down. Raise your hands if you did weight 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. Yeah, that's 21 of us. Cool. Which way would you like me all to do this? Do you want me to do both ways? 1,
Okay, I'm going to do both ways. Okay, we're going to do both ways. I'm going to start with way 2, because way 2 is a little bit faster for me. Way 2. And then I'll do way 1, I promise. So what do we all start with either way? Asymptote. What am I setting equal to 0? X plus 3. So x equals -3. Great, we got our asymptote. Now I'm going to make my table. I'm just going to do 2 rows for this. We got x, we got a y. My base function is y equals log 5 of x. Okay, my base is what again? 5. So I have 1 over 5, because that's 1 over b. Then I have 1, because it's always 1. Then I have 5, which is b. That always equals -1, 0, and 1. You can show the work and do the exponential in the middle, but each way it's going to come out like that. Unless we have a negative, then we switch this 5 and 1/5. Okay. Now do my transformations. What is happening to my x? Am I moving left or right? Left. So we're doing -3. What's happening to my y's? -1 and yes, multiplied by 2. So let's start with our x's. What is 1/5 minus 3? Yep, -14 over 5. 1 minus 3, -2. 5 minus 3, 2. Okay, next row. 2 times -1, Lily, what's that? -2 minus 1. Okay, -3. Did I lose anyone with that? No. Okay. 2 times 0, Ronaldo. 0 minus 1. -1. Okay. Michael, what is 2 times 1 minus 1? Yes. Okay. Those are the points for way 1 or way 2. If you did the log form, you should have gotten the same points. Let's go through the log form as well. So this is way 2. No, way 1. I'm going to get those mixed up. Way 2, way 1. I'm going to keep doing that. What do I have to do to the argument? I have to set it equal to 3 things. What are my 3 things?
X plus 3 equals b. X plus 3 equals 1. X plus 3 equals 1.
Yes, what is my b?
5.
5. So I have equal to 5, equal to 1, equal to 1 over 5. When I do this math, what do I get for all of my x values? So we get 2, -2, and -14 over 5. That's my x. Gotta get my y's. So we do 2 log base of 5. Who did way 1? Okay, I want you to write this book on the board. You want to put it on the board? Your table.
Like with the work in it?
Yeah.
I'll do one of them.
Okay. Lily's going to do 2. Who wants to do -2? Sebastian, thank you. Okay, -14 over 5. Who wants to do the last one?
I think it's a good idea, but it's hard to get.
Yeah, I don't know about to take my noteboard. Noteboard? Are we gonna get all the... You can just use...
Oh, you can do wood. Wood's mine too. Wood's mine too.
On this one?
But you could. No, do it right next to test. Yeah.
Amy.
So they're plugging into our equation, which was x plus. You were doing -2. Shetty's doing -14 divided by 5. If you're at your seat, you should have graphed this equation by now. And so is it the range and asymptote.
So that I don't have to take that. Do I have to? Unless I want to, yeah.
Find the lead, when we have time, we have to like that.
Did you basically clip something on
So Lily plugged in the 2. She got 2 logarithms of 5 of 5 negative 1. And a 5 to the what power gives me 1. No, 5 to the what power gives me 5. 1 thing. Just to the answer. So Shetty is doing my negative 14 divided by 5. She put it in. She got the 1/5, which is my 1 over b inside my log. And she's getting y to equal negative 1. So we get 2 times. So I got negative 3 as her y value.
They're trying to start a mess up, but it's like
Do they look exactly the same? Yeah, they should look the same. Which two? Oh. What do you mean? So it gets multiplied. So we'll get 2, we get a log equals 0, and then 2 times 0 equals 1. Yeah, way 2. Oh, this way. Okay. And so Shetty's 2 right here. So she was down here. She was solving for the log part. She was down here. So she has negative 2 minus 1. Okay, did we get the same points either way? Yeah. Yes. So you can do either way. It does not matter. For who's ever watching this, we got 1, negative 1, and negative 3. Oh, I didn't. Do you guys want me to know?
yeah.
Oh, well, do you want to grab it then up on the board?
I'll grab it.
Yeah, grab it.
I'll grab it on the board.
Grab it next. Okay, we have. Yeah, you can erase that. That was meant to be a joke. Ronaldo's gonna grab it for us.
Why doesn't your hair pull out when you go to big chunky? What if you close one by one?
Oh.
Just give you half of both.
Yes.
I just. If you have it. Yeah. What about my, oh, we already said asymptote. Wait, asymptote. Okay, next one is on the board. We only have 5 minutes, so you can start that, and I'm going to give you guys your homework. But guess what? It's not book homework because the book homework is not good. So, homework is going to be this problem, but I'm going to write it up here. Homework. Graph. State. Domain and range. Ooh. Don't know why that's B. Okay. First one is this is gonna be number 2. First one is gonna be y equals log base 2 of x plus 3 plus 4. Number 2 is gonna be this one, y equals log base 1/3 x minus 3 plus 2. And I'm gonna give you another one. Next, what? No, this is gonna be your homework. You can start it now. Then we have y equals 4 minus log base 2 of x minus 1. This negative is going to be very important for way 2. What? Okay. If you're doing way 2 for number 3, my base equation is y equals negative log 2 of x. So that means we have to switch what 2 points? What 2 x values? Yes. The 4 is like plus 4 at the end. I just moved it over to you guys see. Yeah. We're gonna be like plus 4. You're gonna find x and y and graph both foods. Should I give you an inverse too? Okay, fine. We'll talk about inverses a little bit more on Monday. But that's it. I would take a picture. So I don't think I've done that last time.
1 over 1.
You still have to do the example too. I mean, you're like, oh, this is the next one.
He did take
And you wrote it.
So that one right there was this one.
Oh, okay.
Yeah, I would, if you guys were just bored while we were wrapping, you could draw on that. They don't draw on this one.
Just walking your baby in this. Why are your hands all the way next to you?
You guys could start now and ask a question.
What if the base is E?
The base is E.
Oh my gosh.
Well, then it'd be ln, right?
Oh, yeah.
Yeah. So that it looks very, very close to a log, but it has log base E. So the base is what? 2.7 blah blah blah. Yeah.
She didn't know. She took a big old sip of water and she fell in her mouth.
Oh.
She spat it out, the fly was still on.
Okay, just last little thing. I am here all day tonight, all night tonight until super late. I'll put a thing up out in front of my door that says the name schedule and stuff. Sorry that wasn't on the announcement. If you need a quiet place to work tomorrow, and home just isn't that place, I will be here all day long. I have no issue if you come in. Parents obviously take priority, but if you just need a quiet place to work, and you want to sit in the art room while parents are in here, or if you need my help or this week's help, feel free to come in. Peace out. See you Monday.